Welcome to this webinar on collecting and analysing data using the 7 quality tools. My name is Catherine Boyle and I'm an Operational Excellence Coach with Invest Northern Ireland. The Operational Excellence Solutions team are trained coaches with numerous years of business experience across a wide range of sectors and sizes of companies. We work with Northern Ireland businesses to improve their productivity, profitability and competitiveness, and we offer tailored support using a combination of training, mentoring and coaching to promote best practice and to build capability within our clients' businesses to deliver quantifiable and sustainable improvement. If you have any queries or you want some more information about the support that we offer, please send your requests through to opexquery@investni.com. During this short webinar, I'll talk about the importance of collecting and analysing data when you're solving problems in your business. I'll take you through each of the 7 quality tools, including how to use each one, how to choose the most appropriate tool, and how to interpret the data trends and patterns you've observed. When we're out working with companies, we often get asked why you should go to the trouble of collecting data instead of just getting stuck into fixing a problem. Well, gathering facts and data makes solving the problem easier and considerably faster. It helps provide clarity and insight into what's actually happening by asking questions to get a better understanding of the situation. Dealing with facts and figures removes ambiguity and assumptions. Analysis helps you to organise, interpret and structure the raw data, making it easier to identify trends and patterns. And most importantly, using data to solve problems helps identify the root causes rather than constantly firefighting and putting quick fixes in place to manage just the symptoms of the problem instead of treating the root cause. When you're planning data collection, you want to ensure that you're gathering information which will answer the following questions for you. When does the problem occur? Where is it located? This could be either physically or virtually on a particular system or online. What does it consist of? What are the symptoms? Who's involved? Why is it happening if you know this? And how does it happen? Before you start collecting data, you'll need to decide in advance what information you need. Think about what types of data will answer your questions. Don't reinvent the wheel. Use information that's already available whenever possible. Create a standardized form to collect the data and one to summarize it as well. Include as much detail as possible so that data collection can continue even when you're not there, for example, on other shifts. Pilot your data collection method. Don't be afraid to try it out, and you can make changes or improvements if needs be. As you start collecting and analysing data and getting a better feel for what the problem is, you'll be able to fine-tune your collection methods and narrow your focus to collecting more specific and relevant data. Develop a plan for collecting data to make sure that you get all the information you need to solve the problem. This is a simple template that can be used for planning your data collection. Start with what you're going to measure. What type of data are you collecting? Is it continuous data being recorded over a period of time? Or are you only recording information anytime a particular event occurs, which is called discrete or categorical data? Define the details of what you want to record. Be as specific as possible so that anyone can collect the data on your behalf. What are the stratification factors? In other words, are you recording data by time of the day or month of the year or by employee? Include any other details in the sampling notes that will help clarify what information needs to be gathered. And finally, make sure you plan who will be involved in collecting the data and how this will be done. Do you need any special equipment or are extra resources required? Here's an example of a completed data collection plan for a restaurant. One of the items they want to look at is the length of time customers have to wait to pick up their takeaway orders. They're sampling every pickup order, so this is continuous data. Then the next column gives specific details of what exactly they want to measure, i.e. the cycle time in minutes from the moment a customer walks in the door to when the pickup order is given to the customer, so it's totally clear to anyone collecting the data exactly when to start and stop timing. The last thing you want is to collect data all day long and then realize everyone's been doing something slightly different and you have to start all over again tomorrow. In this case, there are no stratification factors, so all servers and types of customers are being measured throughout both the lunch and the dinner rush times. The sampling notes then give a little bit more detail about the sampling process, and there's also information here about who will be taking the measurements and how they're to be taken. I've talked so far about why you should collect data and how to plan what you want to know. Now I'll move on to how to actually go about gathering the information you need. In other words, what tools you will need. Just to give you a bit of background on the 7 quality tools. So why 7 tools? Well, traditionally, a Japanese samurai carried 7 tools when he went into battle. The 7 quality tools were developed by Kaori Ishikawa, who was a professor of engineering at Tokyo University. He came up with these 7 basic visual quality tools to allow the average person to collect and analyze data, which can be used to solve 95% of all problems. These are now used all over the world by employees at all levels, from operators to senior management, to gather and interpret data. I'll start by giving you a quick overview of these 7 visual quality tools, and then I'll go into each one in more detail later, including when and how each one is used. Check sheets are structured forms for collecting and analysing data. They're a generic tool that can be adapted for a wide variety of purposes. Histograms are the most widely recognised of the quality tools. They're commonly used for showing frequency distributions or how often each different value in a set of data occurs. A histogram allows you to visualise the shape of the distribution and the spread or dispersion of the data. Pareto chart is a type of bar graph used to show which factors are the most significant. It's based on the principle that 20% of the input generates 80% of the result, but I'll talk a bit later about how the Pareto principle works. Control charts are used to study how a process changes over time and will tell you whether the process is in control or out of control. Scatter diagrams are used to graph pairs of numerical data with one variable on each axis in order to study and identify a possible relationship between the two variables. Process maps are flow charts which allow you to visualize the flow through a process and identify key decision points. Fishbone diagrams can also be known as cause and effect or Ishikawa charts. They're used to give some structure to brainstorming by helping to identify all the potential causes for a problem and sort ideas into useful categories. I'll now talk about each of the 7 quality tools in more detail, starting with check sheets. A check sheet is a simple means of collecting and tracking information. It distinguishes between opinion and fact, and it's used to determine how often a problem is occurring and gather data about the type of problem that it is. When you're designing your check sheet, think about what type of data you're collecting. Is it variable or numerical data, for example, a measurement, quantity, period of time, etc.? Is it attribute data, in other words, pass or fail, or is not, etc.? Or is it subjective data like opinions or something which requires a judgment call? Think about how the data will be organised. Specify the time period, including how often samples will be taken. Who will collect the data? Once you've all this information, you can design the check sheet according to what you need. In other words, is it going to be data sampling, a survey, a tally sheet, etc.? Histograms are one of the most widely recognised of the 7 quality tools because they give a quick image of how a process is behaving and they're easy to interpret. They're used for numerical data to see the shape of the distribution and the dispersion or spread of the data. The values are divided into intervals along the x-axis called bins. In this example, the height of school children in a class. The bars represent the number of observations or frequency within each bin on the y-axis. In this example, the number of children of each height. In the histogram shown, there are 2 children with a height of 120 centimetres and 1 with a height of 110 centimetres. You can also see clearly that the majority of the children in the class are from 125 centimetres to 145 centimetres tall, with just a few outside this range. There are also 2 spikes, which would suggest that there are both boys and girls in the class. When you're constructing a histogram, collect the data and sort it into categories or groupings, for example, 120 centimetres to 130 centimetres. Each mark on either axis should be in equal increments. Plot the independent set of data or the data categories or bins on the x-axis and plot the dependent data or frequency on the y-axis and show the data as a bar chart. When you plot your data as a histogram, the shape of the distribution will tell you a lot about the process you've collected data on. The most common pattern of distribution is referred to as normal distribution. The histogram will be shaped like a bell with a central peak and a tail at both sides, which is what you would expect to find for most processes. If the histogram has two peaks in it, this suggests that there are two data distributions. A ragged or plateau-shaped distribution shows that there is no clear pattern or trend in the data. For data which is skewed to one side with an off-center peak, have a look for other processes in the tail of the distribution. If the distribution is truncated, like in this last image shown here, you'll need to look for reasons for the sharp end or lack of tail on one side of the data distribution. The histogram will also give you a feel for the spread or dispersion of the data for your process. If you draw a vertical line on the plot, which shows what the target value is for the process, for example, 30 hits on your website per hour or 500 grams filled into a bag of apples, etc. Ideally, you want the peak of your distribution to be as close to your target as possible, like in the histogram in the middle here. If you draw vertical lines on the plot, which show the lower and upper spec limits or tolerances, you'll be able to tell at a glance how much of your product or service is able to meet the customer's requirements. In this case, the distribution extends beyond the spec limits, which suggests that either the tolerance is too tight or that the process is not capable of achieving the required specification. The principle behind the Pareto chart is that a large majority of problems are produced by a few key causes. For example, 20% of your customers will generate 80% of your revenue, or 80% of problems are caused by 20% of potential sources. A Pareto chart is a type of histogram or bar graph used for analyzing data about the frequency of problems or causes in a process. The data must be collected and classified into types, for example, reasons for customer complaints, categories of safety incidents, etc. This quality tool is best used when there are many problems or causes and you want to focus on the most significant to get the biggest return for your effort. The heights of the bars represent frequency or cost, so the chart visually shows which causes are the most significant, which makes them a good tool to use for communication about the problem. In a Pareto chart, the bars are arranged with the longest bars on the left and the shortest to the right, so you can tell at a glance which causes are the most significant. When you're constructing a Pareto chart, start by arranging the factors or causes from highest to lowest in terms of frequency of occurrence. Then create a bar graph using vertical bars to represent each factor or cause. Then add up the total number of issues or incidents and calculate the percentage of total issues due to each factor. In this example, 42% of incidents were due to slips. Work out the cumulative percentage of all factors when they're arranged in order from highest to lowest in terms of frequency. For example, the cumulative percentage under fall is the sum of the individual percentage of incidents due to slips, trips, and falls, and the final category should have a cumulative percentage of 100%. Mark the cumulative effect on the chart above each bar and draw a curve linking the cumulative effect points. Then draw a line from 80% to the curve and drop down to the x-axis. So your Pareto chart's now complete and you need to focus on the factors or causes to the left of this line to have the most impact. In this example, reducing slips and trips will have the biggest effect on the total number of incidents. Control charts show the behavior of a process over time and can be used to monitor the behavior of critical process parameters with time. They can be used to determine if the performance of a process is stable or not. In other words, if the process is in control or out of control. All processes exhibit variation, which may be either natural random variation, which is inherent in all processes due to common causes, or special non-random variation due to special causes. I'll talk about different types of special causes a bit later. When you're constructing a control chart, you need to identify the critical process variable that you want to focus on. Measure this process variable over time and record the data in sequential order. Make sure you use an appropriate scale that ensures that all data points are visible on the graph. Plot time on the x-axis and the variable being measured on the y-axis. Calculate the upper and lower control limits of the process and show these as horizontal lines on the graph, and these can be updated as the performance of your process improves. The presence of unusual patterns, even when these are within the control limits, can still be warning signs indicating that the process may need to be corrected. The first graph shows an upward trend, which may be perfectly normal, but whenever there are 7 or more consecutive points in an upward or downward trend, this should be investigated. In this case, the presence of an outlier, particularly one which is outside the process control limits, is worth looking into. A sudden or even gradual shift in the variable being monitored could indicate a potential issue in the process. And cyclical variation is also worth investigating to try to understand what's causing this. You may find a link between this trend and, for example, time of day or shift pattern. Scatter graphs compare pairs of numerical data to look for a relationship between them. They're used to test for cause and effect relationships, but it's important to note that they cannot be used to prove that one variable causes the change in the other, only that a relationship exists and how strong it is. The suspected cause is plotted on the x-axis and the effect is plotted on the y-axis. If the two variables are correlated, the points will fall along a line or curve, and the better the correlation, the tighter the points will hug the line or curve. When you're constructing a scatter diagram, collect data for 2 different variables and create a summary table of the data. Plot the data on a graph with the cause or independent variable on the x-axis and the effect or dependent variable on the y-axis. Examine the trend in terms of both direction and strength of correlation. In other words, is there a positive or negative correlation and how strong it is? In the first scatter graph shown here, the points are clustered tightly around a line, which suggests a strong correlation between the two variables. Also, when one variable increases, the other also increases, which means it's a strong positive correlation. In the second graph, the points are further apart, which suggests that there may be a weaker positive correlation. In this scatter diagram, there doesn't appear to be any correlation between the two variables. Here, the correlation is weak, and when the cause increases, the effect decreases, which suggests that there may be a negative correlation between the two variables. This graph shows what a strong negative correlation looks like. A process map is a visual representation of the movement or flow of orders, materials, people, and data through your process. Depending on what the problem is you're trying to solve, you may want to map the entire process from receipt of an order through to the delivery and payment, or just a small section of the process. You need to determine what the boundaries of the map are before you start. Then decide what level of detail you need. Is a high-level overview sufficient, or do you want to include every task that's carried out? Sometimes it can be useful to map the high-level process first, and then you can drill down in more detail into 1 or 2 process steps where the problem's arising. When you're mapping out a process, it's important to map the actual process, not what you think it is or what it should be. Make sure you include the rework loops, shortcuts, and different variations. And it's really important to make sure you actually walk through the process following an order through from start to finish. Ensure that you involve those who actually perform the different tasks to capture what really happens. It can also be valuable to include the process manager, suppliers to the process, and those involved in the next process step downstream, in other words, the internal customers. What sequence do the tasks follow? Does everyone follow the same sequence? When we map processes in business, we use post-its, which can be easily moved around if needs be, as it can sometimes take time to capture the agreed process flow. This is a simple process map for making a cup of tea. In terms of the boundaries, we're focusing on the actual tea making process, not what happens before or afterwards. The first step is what triggers the process to take place. In this case, I want a cup of tea. So the first things you do is check you have the ingredients, check how many cups you need to make, fill the kettle, boil the kettle, get cups from the cupboard, get the teapot from the cupboard, check how you take your tea, put tea bags into the teapot, put water into the teapot, pour tea into the cup, Then you have your first decision. Do you take milk? If no, skip to the next step. If yes, add milk. Then the next decision is, do I take sugar? If no, skip to the end. If yes, check how many sugars, add sugar, stir the tea, and enjoy your cup of tea. If this is your process and the customer reports that there's an issue with the final product quality, in other words, the customer says that the tea is just undrinkable, you may need to go back to them for more information to help you to narrow down which steps may have been the problem. Was there too much or too little milk or sugar? Was the tea too weak or strong? Or was it a temperature issue? If it turns out that the issue was that the tea is too cold, you know that something has gone wrong at one of 3 points in the process. So either the kettle didn't boil properly, or this step was skipped out, or too much milk was added, or there was too long a delay between the kettle being boiled and your tea being drunk. You may then decide to investigate these steps further, collect some data, or map them out in more detail to help you get to the root cause of the problem. The cause and effect diagram is also called an Ishikawa after its creator, Kaoru Ishikawa. It's often described as a fishbone diagram because it looks like the skeleton of a fish. The problem or the effect is at the head of the fish. The major causes of a problem are the ribs, and the detailed causes are the small bones. All potential causes identified during brainstorming are grouped under 6 headings. Method, in other words, how we go about doing the work. Machine, for example, breakdowns or computer or software issues. Manpower, for example, staff shortages and training. Measurement, in other words, how we measure the system or if there's any bias in the measurement. Materials, for example, different suppliers, out of spec supplies, availability of materials, etc. Mother Nature or environment, for example, a machine running too hot or too cold, or even something like legal issues, external social, political, or economic factors. Then think about which of these inputs we're in control of and which we're not in control of. What control measures can we put in place? Using a fishbone diagram during a problem-solving brainstorming session gives structure and direction to the brainstorming process by listing and grouping all possible causes under the 6 headings. Once you've exhausted all ideas, get the team to vote on what they feel are the most likely causes and use data to verify or eliminate these. When you've confirmed the actual causes, carry out a 5 whys analysis on each one to help find the root causes. Here are some do's and don'ts around brainstorming. Assemble a group of people, some of whom are familiar with the problem area, as well as some others from outside the department who can be objective and challenge assumptions. Have people write down as many ideas as they can think of in 5 to 10 minutes and have all the ideas presented. Group ideas, eliminate any duplicates. Apply the ideas to the cause and effect fishbone and commence discussion and voting. Don't phrase the problem to be discussed in too specific terms. Don't allow any discussion or criticism. Don't discount any ideas, even though some may seem a little far-fetched because they may trigger another idea in someone else's head. And don't rephrase the suggested cause in case of misinterpretation. So just to summarize on what I've covered in this webinar, data collection and analysis makes problem solving easier and faster. It's important to plan the data you need to collect before starting. You may use some or all of the 7 quality tools for collecting and analysing data. 7 quality tools are check sheets, histograms, Pareto charts, control charts, scatter diagrams, process maps, and cause and effect diagrams. If you want any more information on anything that's been discussed during this session, please get in touch by emailing opexquery@investni.com. Thank you for listening.